One of the key challenges in the development of the technology for urban air mobility is said to be the power. Now we're with Phil Whiffin, who is the head of Advanced Propulsion Systems at Warwick University, who we're going to talk to about this. Phil, welcome to the program. Batteries seem to be one of the biggest challenges that we have. What's happening? Why are we not getting it right?
Well, I think we are making great progress. I mean, batteries are the big constraint to any vehicle. So they define how far you can go, how fast you can go. They're going to define, because they're such a large part of the vehicle, the mass of the vehicle. So people will always want more. They'll always want to drive further, fly further. They'll always want to go faster. And the battery constrains that. And we've made massive progress in the last few years. Batteries have come down in cost 4 times. We've got the energy density and the power density to 280 watts per kilogram, for instance, which is really quite impressive. But we're not ever going to compete with fossil fuel. So the energy density of a battery is always going to be 40 to 50 times less than equivalent fossil fuel. So you're going to have to change your behaviour, and that will affect the vehicle and the way the vehicle operates. But we are making great progress.
So what really comes first? Is it the design of the vehicle, or the design and the weight and the constraints of the battery, that then you design the vehicle around that?
That's a really good question. So what's happened in the past is that the vehicle's been designed and then a battery's been tried to be put into that vehicle. And that's not efficient. That's not an efficient way to design the whole system. The most efficient way is to design it as a whole. And the battery then can be designed for that particular utilisation, for that particular mission profile. So you've got the right size battery. Also, in thinking about the vehicle as a whole, for instance, if you can make the vehicle 5% more efficient, you need a 5% smaller battery. So you can achieve your mission profile in a number of different ways, and it's not all about just having a more power or more energy in the battery.
Now at WMG and within Warwick University, you're dealing with a fair number of the people that are doing it. How do you do that? Because you're in competitive areas.
Well, we don't sell anything as opposed to put something into production. But what we do is we have the Energy Innovation Centre, which allows us to take batteries all the way from making the material, making cells. We can make packs, and we can actually we have a make-like production facility that is open. That actually allows people to build full battery packs in. We have battery suppliers who come in and utilise our facility to fine-tune and tailor their own battery facilities that they can do offline. We work with OEMs, we work with suppliers, and because we're not in competition with them, I think they see us as we have the facilities, we have the expertise, and they can work very well with us.
So Phil, just finally, how optimistic are you that we are going to be flying in these urban air mobile equipment in the next few years?
I'm absolutely 100% optimistic. I mean, the batteries are there today that will fit particular mission profiles. If you want to fly 35 miles, you'll be able to do it. It's if you want to fly 70, 100 miles, then you start to struggle. But given mission profiles, absolutely, you could do it today.
And you'd get in one yourself?
I absolutely would. I think I feel safer in the air than I probably would in a car.
Thank you very much.
Thank you.